Let us now study about nodal analysis for capacitive circuits, and this nodal analysis is a very useful technique for analyzing capacitive circuits which are having two or more capacitors as well as two or more batteries in the circuit. Here we just take up the steps for analyzing a circuit using nodal analysis. If we use the steps to be followed in nodal analysis on a circuit. Here the very first step in a given circuit, we need to distribute the potentials. The first step is potential distribution in circuit, in various parts of circuit. How it is done, I'll take up an example to demonstrate the same. But you just remember that the step 1 in analyzing any circuit is the potential distribution, where even if we are not aware about some potentials, we can consider variable potentials in the circuit also. And step 2 is writing equations for unknown potential in circuit. And step 3 is directly solving these unknown potentials, solving equations which we have developed for unknown potentials. So step 3 is just concluding a step where it says the solving equation to calculate unknown potentials. How it is done, we just take up an example which will demonstrate the same. Like say, we are given with a capacitive circuit which I am drawing here in the picture. You can see there are two capacitors connected in parallel combination and one is in series. Say this is 5 microfarad, this is 4 microfarad, this is 6 microfarad, and the combination is connected across a 50 volt battery. And here we are required to find, this example says, in the circuit shown, find the charge on 5 microfarad and 4 microfarad capacitor in a steady state. Steady state means if there is a switch over here and if we close the switch after a long time and the capacitors are fully charged, the state we call a steady state. Now in this situation, we are going to calculate the charges on 5 and 4 microfarad capacitor using the method of nodal analysis. Here in solution, the very first step is to distribute potential in various parts of circuit. Here we are given with a 50 volt battery. So in general, we start distributing our potentials from the negative terminal of the battery, where I can assume that the potential is 0. Or 0 potential assumption is just taken because I am considering all potential in the circuit with respect to this negative terminal. So here if I take 0, the potential on the other side of battery would be 50 volt. So on this whole terminal, the potential can be taken 0 where the wires are connected, and on the other side it is 50 volt. If we talk about this section which is connected with these 3 plates of capacitor, which is neither in contact with 50 volt nor in contact with 0 volt, here I can consider potential to be X. And such sections of circuit we can call as nodes. That's why this method is named as nodal analysis. Nodes are those parts of circuit which are not in direct connection with any other section of circuit. So here, if somehow I'll be able to calculate the value of X, I'll be directly getting the charges on all the capacitors. So here I'm going to write the equation for calculation of X, which is the unknown potential here. And the equation I am going to use is sum of all the charges on the plates which are connected to the potential X, or the node where potential is taken as X, should be equal to 0. Like from this junction or a node, there are 3 capacitor plates connected. And as these plates are neither in direct contact with the left side nor on the right side, so sum of the 3 charges must be equal to 0, because charges can never jump over from one plate to another. So sum of the charges on these 3 plates must be 0. That will be my equation for calculation of X, which you can also call as a nodal equation for X. So here if I talk about this plate, which is a plate of 4 microfarad capacitor, and on one side the potential is X and on the other side it is 0. And we know that the charge on a capacitor is CV. So here it will be, the charge on this plate can be written as 4 multiplied by the potential difference, which is 4x. Here I am making this equation. For this plate, the capacitor is 6 and the potential difference is x minus 0. So charge will be 6x. So this is the charge on this plate, this is the charge on this plate, and for this plate I will write it as the capacitor is 5 multiplied by the potential difference is x minus 50. And this should be 0, because sum of the charges on these 3 plates should be 0. On simplifying this equation, I am getting the value of x is equals to 50 by 3 volt. If I am getting the potential of this node, I can directly calculate all the charges in the circuit. Like if I wish to calculate charge on 4 microfarad capacitor, this will be 4 multiplied by the potential difference 4x. So on substituting the value of x, this is giving me the charge is equals to 200 by 3 microcoulomb. That will be one answer to this problem. Similarly, charge on 5 microfarad capacitor I can write as this will be 5 multiplied by the potential difference, so this 5 multiplied by 50 minus x. Here I am not taking x minus 50 because I need to calculate the magnitude of charge. So if I substitute the value of x as 50 by 3, this will be 5 multiplied by 100 by 3, that is 500 by 3 microcoulomb. That will be another answer to this problem. So here you can see, by using nodal analysis, you can find out unknown potentials of the circuit. Like here we have taken x and calculated the value of x by using an equation which says the sum of charges connected to the node should be equal to 0. And simplifying it, we get the value of potential, and once you get the potential, you can easily find out all the parameters of the circuit.